All right, let's dive in. We're going to be talking about the incredible and, let's be real, sometimes incredibly complex world of Grafana. We're going to go from the 30,000-foot view of its observability stack all the way down to the nitty-gritty, in-the-trenches reality of making this stuff work at a truly massive scale.
So first things first, why do we even need this? Well, it's because modern systems are they're a tangled web. And to have any chance of figuring out what's going on inside, you need what we call observability. It all stands on these three pillars. You've got metrics, which are your numbers, logs, which are the story of what happened, and traces, which follow a single request on its journey through your whole system.
And what's really key here is that observability isn't just about hoarding data. It's about being able to ask completely new questions about your system on the fly without having to deploy new code. It's the power to really understand the why behind whatever's going on just by looking at the signals your system is already giving you.
So here's how we're going to break it all down. We'll start with a big challenge, then see how Grafana tries to solve it. We'll get into Loki's pretty radical take on logs, look at a wild, real-world scaling story, and then wrap up with how you can get your own stack ready for prime time.
Okay, so you've got all these different monitoring tools, right? It's a mess. So what's Grafana's answer? Well, its big promise is to be your single pane of glass. One unified dashboard where you can see absolutely everything.
And to actually deliver on that promise, Grafana has this whole open source ecosystem. You've got Prometheus and Mimir for your metrics, Tempo for all your traces, and of course, Loki for logs. And the core Grafana is what brings it all together visually. Now we're going to zoom in on Loki because its whole design philosophy is where things get really, really interesting. And that brings us to Loki. Its approach is, well, it's different. It's almost backward from what you'd expect. See, most logging systems try to index every single word to make searching super fast. Loki does the exact opposite. Its big idea is that by indexing less, you can actually do a whole lot more, or, at the very least, do it for a whole lot cheaper.
And here's that fundamental trade-off in plain sight. You have traditional systems like the LK stack that do full-text indexing. Think of it like a perfectly indexed reference book. You can find any word instantly. But that index is massive, and it costs a fortune in storage and compute. Loki, on the other hand, only indexes the metadata, the labels. It's like only indexing the chapter titles. It's way cheaper, the indexes are tiny, and getting data in is super fast. The catch? If you need to find one specific word inside a chapter, Loki has to read the whole thing.
And this isn't just some theoretical debate. You see it play out in the real world all the time. This comment from Reddit just nails it. People love Loki because it's so easy to get up and running. But the moment you hit a massive scale and you have to run those big brute force searches, that minimalist design can really start to creak. So what happens when at scale means the scale of Grafana's own cloud service? Well, they ran headfirst into this exact problem. And how they solved it is just a fantastic story of some really smart, pragmatic engineering. To fix a huge problem they were having with their object storage. Basically, their cloud provider was throttling them for asking for too many logs at once. The team at Grafana Labs set a wild goal. They decided they needed a 50 terabyte cache. I mean, that is just a staggering amount of data to keep ready to go. Now, if they tried to build that 50 terabyte cache the old school way, just using RAM, the cost would have been insane. We're talking over $200,000 a month. Just not going to happen. It was a complete non-starter. But by thinking outside the box, they found a solution that wasn't just possible, it was shockingly efficient. They hit their 50 terabyte target, and they did it by slashing the projected cost by an absolutely mind-blowing 98%. So, how in the world did they pull that off? You guessed it, another smart trade-off. Instead of crazy expensive, super fast RAM, they used local SSDs. Now sure, SSDs are a bit slower than RAM, so their cache latency went up a little, but they are so much cheaper, and more importantly, this approach completely fixed their number one problem, the rate limiting that was tanking the reliability of their whole service. The secret sauce here was a feature in Memcached called Extern Store, and it's just brilliant. It keeps all the small index keys in that fast RAM for quick lookups, but it shoves the big, bulky log data onto the much cheaper SSDs. And the best part? It was a drop-in fix. They didn't have to change a single line of Loki's code. Genius. Okay, that was a pretty epic journey into the deep end of scaling, so let's zoom back out. For the rest of us, what does it actually take to get a Grafana instance configured, secured, and ready for the real world? First up, config. Grafana has a really simple, really powerful system. You've got your main grafana.ini file that sets all the defaults. But for production, the absolute best practice is to override what you need with environment variables. The format is always the same: gf, then the section name from the ini file, then the key. This makes managing your setup in Docker or Kubernetes an absolute breeze. Now, for security, I find it really helpful to think in terms of the 4 A's. First, you've got authentication, proving who you are, probably with something like LDP or OAuth. Then there's authorization. Now that we know who you are, what are you actually allowed to do? That's where Grafana's roles come in. Third is the audit trail, keeping a log of who did what and when. And finally, administration, how you actually manage all of this stuff, which is right there in the UI. So, what's on the essential checklist? Number 1, tie into your company's existing authentication system. Don't create a bunch of new users you have to manage. Number 2, and please do this first, change that default admin password right away. After that, make sure you set up HTTPS, lock down who can query which data sources, and ship your audit logs off to someplace safe, maybe to your own Loki instance, right? And that kind of brings us full circle. The dream of that single pane of glass is powerful. It's what we all want. But as we've seen, from Loki's design to scaling a massive cache to just locking down your own instance, with that great power comes a whole lot of configuration. And it makes you ask the question, is that perfect unified view really worth the complexity it takes to build and maintain it? That's a question every single team has to answer for themselves. Thanks for tuning in.